Good morning. Today we will start solving exercises about algebraic expression. It's on page 59 on your book. So let's see the exercise. Write a monomial m of variable x, degree 3 and coefficient 2. The variable is x. We don't know its value. That's why we say it's an x. It could be any number. Okay, it's with degree 3, so it's power 3, and coefficient 2. Coefficient is the number that is before the variable. Okay, x is the variable, 2 is the coefficient, it's the number that is before the variable. It could be a positive, a negative number, even a fraction. It could be any number. Okay, it's degree 3. Power 3. Now, second part, write a monomial n. Okay, what are the conditions of variable y? This is the variable y. Coefficient 3. Coefficient is the number that is before the variable. And degree 2, this is degree 2. That's how we read it. This form of writing is called a monomial. It has a variable, a letter, unknown value, with coefficient, the number that is before the variable, and the degree that's written above. Okay, that was exercise 1. Now, let's move to the second exercise. To multiply two monomials with each other, for example, let's start with the first one. This is exercise 2. Okay, what should we write here? P equal minus 2x cubed times 3x squared. How to multiply them? First of all, when we say minus 2x cubed, it's 2 times x cubed. There's a multiplication sign here. And in multiplication, I can say 2 times x times 3, or 2 times 3 times x, so they are both the same. So this one can be written as minus 2 times 3. I'm talking about multiplying the coefficient with each other first, then multiplying the x's with each other. Okay, now minus and plus, so it's minus. 2 times 3 is 6. Now let's move to the variable x power 3, times x power 2. We know from the previous lessons that when we multiply a power m by a power n, when we have the same base but with different exponent, and these bases are multiplied by each other, okay, again, the same base with different exponents, I have to write the base and add the exponents. Okay, that's the rule. So here, when we say x3 times x2, I have to write it's x power how much? Let's add the powers by each other. 3 plus 2, 5. In other words, why did I do that here? Look, we have x power 3 times x power 2. What do you mean by x power 3? It's x times x times x. Okay? Times x power 2, it's x times x. So how many x's are there? 1, 2, 3, 4, 5. 5 x's multiplied by each other, so simply I can write them x to the power 5. Okay, that's how we solve it. We have the same base, which is x here. I write it down. Okay, 3 plus 2, I have to add the exponents. 3 plus 2 is 5. We can directly use the rule and add the exponent when we have the same base down here. Okay, now let's move to another one. Q equal minus x cubed times minus x cubed. Here we have minus, so the coefficient is minus 1. And here we have minus 1. Now I have to multiply them by each other. We know that when we have even number of negative signs, the number is positive. In other words, I say that minus times minus is plus. Now let's multiply the variables. X cubed times x cubed. As we said before, we have the same base, which is x, so we have to write it down and we have to add the exponents. 3 plus 3 is 6. So that's how I multiply monomials by each other. Now, another one. R equal minus 3x times minus 2x squared times minus x cubed. Here, whether we have two monomials or 100 monomial, the same rule is applied always. Here, we have minus 3 times minus 2 times minus 1. Minus times minus plus times minus minus. In other words, how many negative signs do I have here? 1, 2, 3. 3 is odd. And since we have odd number of negative signs, so the result should be negative. Now, let's multiply the coefficients by each other. 3 times 2 times 1, which is 6. Let's move to the variables. X. Definitely we have x, since x is multiplied by x squared by x cubed. Here, x, it's to the power 1. And x power 2 times multiplied by x power 3. Simply, we have same base, different exponents. I have to add them. 1 plus 2, 3, and 3 plus 3 is 6. So our answer is minus 6x to the power 6. Okay, here the variable is x, the coefficient is minus 6, and the degree is 6. Let's continue. S equal minus 4 over 3 x2 times minus 9 over 2x. The same rule is always applied. I have to multiply the coefficients by each other. Here we have minus and minus. It's a plus. Positive. Since the negative multiplied by each other, we have even number of negative signs multiplied by each other, so it's always positive. Now, what about 4 over 3 times 9 over 2? Here, we know while multiplying fractions, I have to multiply the numerators by each other and the denominators by each other, right? Or I can simplify first, we will see it. 4 times 9 is 36, and 3 times 2 is 6. So the result will be 6. Or I can simplify first. If I have 4 over 3 times 9 over 2, I can say here 9 divided by 3 is 3, and 4 divided by 2 is 2. Now I have 2 times 3 is 6. Or simply you can use your calculator to check up the answer. Okay, here I told you how did I solve it. Now we have 4 over 3 times 9 over 2, it's 36 over 6. We multiply the numerators by each other and the denominator by each other. X2 times x, it's x to the power 1. Same base, I read the base and I add the exponent, sorry. 2 plus 1 is 3. Now, here we can simplify. 36 divided by 6 is 6, so it's 6x to the power 3. The variable is x, coefficient is 6, and the degree is 3. Okay, now the last part in this exercise, minus 2 over 3 times minus 3 over 4 times minus 2. Minus times minus times minus, so the result should be, we have odd number of negative signs, so it should be negative. In other words, minus times minus is a plus, plus times minus is minus. Okay, here what do we have? We have 2 over 3 times 3 over 4 times 2. We multiply the coefficients by each other, and then we have to multiply the variables. X power 2 times x power 2 times x power 2, it's x, and when we add the exponents, 2 plus 2, 4 plus 2, 6. Okay, now we have minus 3 divided by 3. We can simplify them. Here 2, it's 2 over 1. 2 times 2 is 4, and the denominator is 4. We have here x power 6 minus 4 over 4 is 1, x power 6. Here we can write it, or simply we cannot. Why? 1 times x is x, 1 times y is y, 1 times a is a, and so on. Now exercise 3. Consider the algebraic expression a of x equal 4x squared minus 4x minus 3. Calculate the numerical value of the expression in a in each of the following cases. We have to calculate the numerical value. I have to find the value of a of x in these four cases. Let's start by the first one, if x equal 0. What should I do here? Okay. First part, if x equal 0, I have to replace this x by a 0. So I can say a of 0. Here it's a of x equal 4x squared minus x minus 3. Here a of 0, simply I have to replace these x's by zeros. How? It's 4 into 0 square minus 0 minus 3. 0 square is 0. 4 times 0 is 0. And here we have, okay, let's write it. 0 minus 0. I can write it or not, it's the same. Here we have minus 3. 0 minus 3 is minus 3. Okay, it's so easy. I have just to replace x by 0. That's it. Now, the second find the value of a of x if x equal 1.5. So I have to find a of 1.5. What should I do? Let's replace x by 1.5. So it's 4 into 1.5 squared minus 4 into 1.5 minus 3. Okay, by applying priority rules, exponent has more priority than multiplication or subtraction, so I have to start with it. Equal 4 times 1.5 sorry, 1.5 squared is 2.25 minus 4 times 1.5 is 6 minus 3. Here we have multiplication and subtraction, so priority goes to multiplication. Let's remind you, it's about pandas. The priority goes for parentheses, then exponent, multiplication, division, addition, and subtraction. And we know that multiplication and division have the same priority, so I have to start from left. I have to start from left to right when we have multiplication and division, and similarly with respect to addition and subtraction. Here we have multiplication and subtraction, so the priority goes to multiplication. 4 times 2.25 is 9. And we drop down the other numbers. 9 minus 6 minus 3, it's 3 minus 3, which is 0. So a of 1.5 is 0. Okay, it's so easy. What should I do? I have to replace the x by its value, then applying priority rules, and you can use your calculator to check up the answer. Okay, now the third part is if x equal 1 over 2. Okay, let's do it together. If x equal 1 over 2. What should I do here? It's a of 1 over 2. Okay. A of 1 over 2 is 4x squared. So it's 1 over 2 whole squared minus 4 into 1 over 2 minus 3. As we said here, priority goes for exponent, then multiplication. Okay, so 4, since it's square, here the rule is when we have a over b, for example, all to the power m, then it's a power m over b power m. Power m should go to the numerator and denominator. So here it's 1 square, which is 1, 2 square, which is 4, minus 4 times half, it's 4 over 1. We have multiplication here, so I have to multiply the numerators by each other and the denominators by each other. 4 times 1 is 4, and 1 times 2 is 2. So what to do here? 4 over 1 times 1 over 4, it's 4 over 4, which is 1, minus 4 over 2, 2 minus 3. Now, 1 minus 2 is minus 1. Minus 1 minus 3 is minus 4. This is the answer. Now, let's move to the other part. The last part here, they told me to find the numerical value of A if x equal how much? Minus 1 over 2. Okay, this is part 4. If x equal minus 1 over 2, again, let's find A of minus 1 over 2. So it's 4 into minus half squared minus 4 into minus half minus 3. Now, minus square, it's minus times minus, which is a plus. The rule is the square of any number is always positive. So it's plus 1 square 1, 2 square is 4. Minus times minus is a plus. 4 over 1, multiply the numerator by each other and the denominator by each other, it's 4 over 2 minus 3. We drop down the other number. Here we have 4 times 1 over 4 is 1, plus 4 over 2 is 2 minus 3. So I said when we have addition and subtraction, I have to move from left to right in this direction. 1 plus 2 is a 3, and we have minus 3, so the value of A of minus half is 0. Okay, that's it. Please, you have to write the answers on your classwork copybook, and don't hesitate to ask me if you have any question. Take care of yourselves. Bye bye.